Hey guys, this is 3.1. We're going to work on the coordinate system and how to graph points on that coordinate system. Okay, so we're going to start with plotting ordered pairs. When it says ordered pairs, it just means a pair means two, right? So it's two numbers in order. What I want you to remember about ordered pairs is they always go. So you open, excuse me, that first, when you have a pair of parentheses. The first pair is the opening, the first of the pair is the opening of the parentheses. The second is the closing of the parentheses. So we're going to open the parentheses, and then after the parentheses, the first number is always the x value of the pair. The second number is the y value of that pair. The second term is the y value. What that means is we're talking about the coordinate system. The coordinate system is two number lines that cross each other. All right, so here you have this number line we're familiar with, right? In the middle is 0. If you move to the right on the number line, you're going higher. If you go to the left on the number line, you're getting lower, right? So 1 is lower than 2, -4 is lower than 3, or less than 3, I should be using. -4 is less than -3. 0 is less than 2. 7 is greater than 5, right? That's how the number line works. Right here is called the origin because that's where 0 is. And then we have another number line that instead of going from left to right, goes kind of like north to south, right? So they've crossed each other right at 0 and 0. So that's called the origin. And then this number line, as you go up, you get higher. As you go down, it goes lower, right? Or greater than, less than. So 1 is greater than 0, but -1 is less than 0. So that's what we mean when we talk about the coordinate plane. X values means where it is on the x-axis or where it is from left to right. The y value means where it is on the y-axis or where it is up and down. Okay, so the ordered pair is just the x followed by the y value. The 4 is the x, the -1 is the y. The 3 is the x, the 6 is the y. State, so it asks us to plot those. That means put them onto this coordinate plane. Add them to the coordinate plane, and then it's going to ask us to state which quadrant each point lies. Okay? So first I just want to plot A, 4, -1. So I'll write it over here. Point A is 4, -1. Okay? When we look at that, we're going to take that as our x value. 4 is our x. -1. I just almost wrote -1. -1 is our y. Good. So here it says our x is 4. You always start at the origin like you're drawing on a map, and you go 4 in a positive direction. Positive direction on the x-axis will always mean to go to the right. So from 0, we're going to count 4. 1, 2, 3, 4, right? And then on the y-axis, it asks us to find -1. So 4 on the x-axis, -1 on the y-axis are these two places. Where do they meet? So if I was going to draw a line at -4, and then another line a line at +4x, and another line at -1y, where do they meet? They meet right here, okay? So -4, from +4 down to -1 is this point, or -1 over to 4. But we always start with the x and then we go to the y. So that is point A because the value is 4, -1. All right. B, they gave us 3, 6. So those are both positive. 3, 6 is going to be 3 on the x-axis, 6 on the y-axis. So go right 3, up 6 for B. What was the next part of the problem? They asked us to tell us what quadrant it's in, okay? I'm going to number these quadrants. These numbers never change, so we just memorize this quadrant. You start at the quadrant where both the x and the y values are positive. So right over here, this is quadrant 1, okay? And then we're going to go backwards, counterclockwise, and just name each of them. So if this is 1, this is going to be 2. You might see it written as no Roman numerals. So in Roman numerals, it would be 1, and then this would be 2, looking like that. Okay. Then we're going to go down. This is quadrant 3, and there are only 4 quadrants, so this is going to be quadrant 4. Again, in Roman numerals, that would look like that. In Roman numerals, 4 looks like 5 minus 1, so it looks like that. Okay, so this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. 1, 2, 3, 4. So we can say that the point B is in quadrant 1. In which quadrant it lies? This lies in quadrant 1. A, what quadrant is that? The x is positive and the y is negative. That's quadrant 4. So we're going to say it's in Q4. And we're just going to continue on with letter C. Letter C is -3, -5. Always starting with x and then y. So -3 on x is over here. So from 0, 1, 2, 3, count in the left direction. And then -5 is down 1, 2, 3, 4, 5. So that's point C. That's in quadrant 3. Okay. D is a little bit more difficult because those are decimals, right? So quadrant D, or sorry, point D is -0.4, 3.5. So when you get to decimals, and we're talking about this first column, right? It's at 0, but 0.4. That is the tenths place. And so what you want to think of is you have between 0 and the number in front of 0. So between 0 and 1, in this case, it's -0. So the next term between -0 and something greater than -0 in the negative direction is 0 and -1. So -0.4. So between these two, you have, imagine 10 spaces, okay? I'm just going to count by twos because I don't have much space. 2, 4, 6, 8, 10, right? So -0.4 is going to be 0.24. So we're just going to count 4 of those 10 places. And then +3, 1, 2, 3.5. 5 is halfway between 0 and 10, right? So -0.4, +3.5. So that's going to be this point right here, right between 3 and 4, because it's 5 out of 10, or half. And then here we have -4 out of 10, so 2 out of the 5 places, okay? So that's going to be D, point D, and that is in quadrant 2. Remember that you can also graph this on Desmos, okay? So when you get to the desmos.com website, go to Math Tools, go to Graphing Calculator, because this is Unit 2 is our graphing unit, and put in the point, okay? So they gave us the point, open the parentheses, -0.4. You can also just write it as -0.4, and then +3.5. They will show you where that's supposed to be, okay? If that helps you. Letter E is 0 and then -7/4. X value is 0. Y value is -7/4. I want you to think about what 7/4 is as a mixed number. You can again use Desmos if you'd like. So we'll go to Desmos. Instead of the graphing calculator, we will use the scientific calculator, and we can just put 7 divided by 4 equals, and it's 1.75. So that might help you if decimals are easier for you than fractions. Okay, so it's going to be between 1 and 2, and it's going to be 75% of the way between 1 and 2, right? Or we can look at 0 on the x-axis, 7, negative 7.4. So we're going to count 7 fours. 1 4 makes 1. 1, 2, 3, 4, 5, 6, 7. So that point is going to be right here, point E. Okay? E is not in the third quadrant nor the fourth quadrant. It's right on the y-axis. So we don't count a quadrant. We say that that is on which axis? That is on the y-axis. How do we know it's on the y-axis? Because our x value is 0 for it. Okay? Then we've got negative 4, 0 for f. Negative 4, 0 means we start at x, take x to negative 4, but don't move up or down on the y because the y is 0. So that's going to be f. It's not in quadrant 2. It's not in quadrant 3. It's on the x-axis. We call this the x-axis. We call this the y-axis. So it's right on the line. We say it is on an axis instead of on in a quadrant. Our last one is just the point G, 0, 0. 0, 0 is at the origin. So you could say it's on the x-axis, you could say it's on the y-axis, but really it's at the origin. The origin is where the x-axis and the y-axis meet. And again, if you put any of these ordered pairs that I'm just calling points, if you put any of the ordered pairs into Desmos, it will tell you where it is. All right? Now we're going to do the opposite. So we have some points here. That's really tiny. We have some points here, and we're going to determine what their value is. Let me see if I can get it any closer. All right, tried to zoom in there. Let's see what we've got. A. Can you see an A here? Yes. A is up there on the x-axis. So you always want to check the x-axis. On the x-axis, we did not move from the origin. So our x is 0. And then how much did we move on the y-axis? We went up to 6. And they nicely have it labeled, so we don't even have to count. Okay? B is way down here. So first, how far did we go on the x-axis? 1, 2, 3 to the left. So negative 3. And then where did we go on the y-axis? We went down again. It looks like 5, right? Negative 3, negative 5 would be the ordered pair for point B. Letter C, on the x-axis, we've got a negative 4. And on the y-axis, that C value is at 5. So that point is negative 4, 5. Letter D, again, start at the origin and then count how far you had to go on the x-axis. We had to go positive 2. And then how far do you have to go down on the y-axis? Negative 3. So 2, negative 3. E is right here. So on the x-axis, we went negative 2. And then did we have to go up or down on the y-axis? We did not, so we put a 0 right there, okay? For letter F, we have right here, from the origin, we went over 7. And then we went up 1, okay? All right, I'm gonna readjust my camera. And that's how you find points. That's how you find points if you're given the ordered pairs, and then that's how you find the coordinates or the ordered pair from the point, okay? For what the reason we're learning about the coordinate system and ordered pairs is because linear equations are just equations where you can graph them, and when you graph them, it's a line. So how do we know that an equation can be graphed? Because there's more than one answer to the equation, depending on what value you put in, right? So this has ax plus by equals c. There's an x and a y, those are both the variables. Depending on what x I put in, I'll get a different y. Depending on what, and so if I put in x is 0, you'll get a different y than if x is 1, x is 2. So you have many answers to the equation. All of those answers you can think of as stacked up right next to the answer next to it in a line. So it's just a bunch of little answers as little points. Each of these points is an answer, and then they're stacked up together and they make a line on the coordinate plane. Okay? So that's what we're talking about when we're talking about graphing equations. To graph an equation is just to take every possible answer of that equation, line up all those answers, and it gives you a line. And the line goes on forever. Good? Okay. So a linear equation in its general form is ax plus by equals c. To be linear, the exponents, x and y, should just look like x and y, okay? They shouldn't have x squared or the square root of x or be in the bottom of a fraction or have an absolute value, okay? So we have the general form. The general form is ax plus by equals c. A much more common form that we're going to use is the slope-intercept form. Y equals mx plus b is the slope-intercept form. It's the same equation can be written as x and y together on the same side, or it can be written as equal to y, okay? So those are just two different forms of the same equation, okay? Now, once you have an equation like y equals 4x plus 5, let's just graph that real quick. Y equals 4x plus 5. Right? So you see that it goes through the point 0, 5. That means that when x is equal to 0, the y will be equal to 5. It goes through negative 1.250. That means when y is equal to 0, the x will be negative 1.25. So remember, when you have the ordered pair, that first term is always x, the first number is always x, the second number is always y. Okay? Now they're asking us to make a table for this linear equation. When you are in Desmos, you can make a table by going up here, hit edit list, and then right here, create table, okay? That's if it's already set equal to y, okay? And then the table is, if the x value is whatever I type in, this says -2, but I could put in 100 if I want, okay? You can put in whatever number you want. When you put in a value for x, we can make a table of what y will be equal if x is something. So when x is -2 right here, and we replace that x with a -2, we're now saying instead of 4 times x plus 5, we're saying 4 times -2 plus 5. 4 times -2 is -8. -8 plus 5 equals 3. So y equals 3 when x is -2. Y equals 5 when x is equal to 0, because 4 times 0 plus 5 is just equal to 5. Okay, so that's what they're asking for when they talk about a table. So let's look at this table. You're welcome to answer this using Desmos, or I'm going to show you how to do it mathematically. Complete a table of ordered pairs for the linear equation and plot the solution. So y equals 4x plus 5. When x is 0, it's going to be y equals 4. Instead of x, we have a 0 plus 5. 4 times 0 is just 0. Y equals 0 plus 5. So y equals 5. When x is 0, y is 5. We'll do another one. What happens when x equals 1? Y equals 4. Instead of times 0, we're going to say times 1 plus 5. 4 times 1 equals 4 plus 5 is 9, right? So when x equals 0, y is 5. When x equals 1, y is 9. When x equals -1, what happens? Y equals 4 times -1 plus 5. y equals 4 times -1 is -4 plus 5, so y equals 1. When x is -1, y is equal to 1. Okay? And when it says plot the solution, what that means is that these become your points. Okay? The table 0, 5 means we have the point 0, 5. The table saying that when x is 1, y is 9 means we can use the point 1, 9. -1, 1 is also a point. So we're converting the table into ordered pair points, and then we can just graph those points. So those points were 0, 5, 1, 9, and the last one was -1, 1, right? Plot those. 0, 5 means 0 on the x, 5 on the y. Next one is 1 on x, 9 on y. And the third point they gave us was -1 on the x, +1 on the y. Now we can graph those. We just graph those by getting a straight edge and drawing a line. So that is the line that represents the equation y equals 4x plus 5. If we go into Desmos, four x plus 5, that looks just like the line that we drew, right? Here's the 1, 9. Here's the 0, 5. And here's the -1, 1. Okay? And they're over here on the table as well. All right, the next one is 4x minus 3y equals -12. If we put this into Desmos, it will not graph it. Watch what happens. I mean, it will graph it, sorry. What it will not do is automatically make a table. So it was 4x minus 3y equals -12. So it will still graph it. Oops. It will still give us some points like 0, 4, and -3, 0. But if we ask it to make a table, it won't do that because it's not set equal to y, okay? You are welcome to set it equal to y by solving for y to get that table if you ever need it in Desmos. But we're going to do the same thing, okay? We're going to make a table by saying, if I put 0 in for x, what do I get for y? So instead of 4x minus 3y equals 12, we're going to be 4 times 0 minus 3y equals -12. 4 times 0 is just 0. 0 minus 3y equals -12. So that's just -3y equals -12. I need to get y alone to find its value, so I'm just going to divide both sides by -3. And my answer is y equals 4 when x is 0. And though it won't give you a table, it will give you the 0.04 on Desmos. There's that point. All right, now it's giving us the y value and asking us to find x. I'm going to write that down over here. So 4x minus 3, and they said y is 0, equals -12. 4x minus 0 equals -12. So that just means 4x equals -12. Divide both sides by 4 to get x alone. And our answer is that x equals -3. Good. All right, our last one, they're asking us, what is y if x is -6? So we have 4 times -6 minus 3y equals -12. 4 times -6 is -24. minus 3y equals negative 12. We're just going to keep solving it, okay? It's a bit more complicated, but we're just getting y alone. Right now, y is being multiplied by negative 3, and 24 is being subtracted, so we're going to add 24, negative 12, plus 24, right? We're going to add 24 to both sides to get 12. That's now negative 3y equals 12. Again, we just divide by negative 3 to get y alone, and we get y equals negative 4. So when x is negative 6, y is negative 4. We can check that on Desmos, even though it doesn't give us a table, by just putting in the point negative 6, negative 4. And you can see how it is on the line. Good. All right, so we have the points 0, 4, negative 3, 0, and negative 6, negative 4. And now to graph that, we're just going to graph 3 points. 0, 4. Negative 3, 0. And negative 6, negative 4. And that will be the graph of the equation 4x minus 3y equals negative 12. 0, 4 is right here. Negative 3, 0 is right here. And negative 6, negative 4 is right down here. Now you might notice that you really only need 2 points to graph something, to graph a linear equation. However, it's good to have 3 points just to make sure that you didn't make a mistake with either of your first 2 points. Good? All right. So they asked us what is special about the above points where x equals 0 and y equals 0. If you look at the graph of a point where x equals 0, we'll go back to this one. So when x was equal to 0, that point was on the y-axis. Good? Here, when x is 0, it's on the y-axis. When the y is 0, it's on the x-axis. Okay, so the rule I want you to understand is that 0, 4, because the x equals 0, that point will be on the y-axis. Similarly, when y equals 0, that point will be on the x-axis. It's on the x-axis because the point is negative 3, 0. It has a 0 for the y value. This is on the y-axis because it's the point 0, 4. It has 0 as its x-axis, as its x value. So we can say all x-intercepts have the form all x-intercepts an x-intercept is right there. So all x-intercepts have the form x and then a 0 for y. Whatever your x value is, and then a 0 for y. All y-intercepts have the form 0 and then a number. So all y-intercepts have 0 for x. All x-intercepts have 0 for y. Okay? So I did mention that you can graph a function with only 2 points. So sometimes the easiest way to do that is to find the x and y intercepts. The x-intercept is going to have y equal to 0. the y-intercepts are going to have x equal to 0. Okay, so it's an easy way to find 2 points on your graph because all you have to do is say when x is 0, what does this equal? That will give you one of the points. When y is 0, what will this equal? That'll give you another point. 2 points can make a line. Okay? So in this case, we're going to find the x-intercept by setting y equal to 0. So when y is equal to 0, what is x? Substituting in the 0 for y. X minus 0 is 0, so x equals 3. That's one of my points. Okay? And then what happens when x equals 0? 0 minus y equals 3. Negative y equals 3. This is kind of a hard one because that's still a negative, so we're going to divide it by negative 1. Negative y divided by negative 1 becomes y. 3 divided by negative 1 is a negative 3. So when x is 0, y is negative 3. Okay? And those are the only 2 points you need. Those are the x and y intercepts. We have the points 3, 0, and the point 0, negative 3. We can graph that going like this. 3, 0. So the point 3, 0 means 3 on the x, 0 on the y. And then our other point was 0, negative 3. That means we go 0 on the x-axis, negative 3 on the y-axis. Connect those. That is the graph. That is the line or the graph of the equation x minus y equals 3. Good? Okay. Now we have 2x plus 10y equals 10. Again, when you're creating a table, you can use any points you want, but it's often easy to use the intercepts because you just get to make one of those values into 0. So if I have 2x plus 10y equals 10, and I'm going to put 0 in for x, I'm going to say 2 times 0 plus 10y equals 10. 2 times 0 is 0. 0 plus 10y equals 10. 10y equals 10. Get y alone by dividing by 10. Y equals 1. Okay? So when x is equal to 0, y is equal to 1. We'll do it again with, that was the y-intercept, right? Now we're going to find the x-intercept by setting y equal to 0. So we start with 2x plus 10y equals 10. 2x plus 10, now y is 0, times 0 equals 10. 2x plus 0 equals 10. 2x equals 10, divide both sides by 2, and we get x equals 5. Good? So my 2 points are 0, 1, and 5, 0. Okay? I'm going to do it on... So my points are 0, 1, and 5, 0. 0, 1 means 0 on the x, 1 on the y. 5, 0 means 5 on the x, 0 on the y. So that's going to be that line right there. And the equation was 2x plus 10y equals 10. Good? All right, and you're welcome to check that. Just type that into Desmos, see if you get the same graph that you found graphing. Okay? Now they're asking us to graph all three of these equations on the same axis or on the same graph, okay? So here we have y equals 2x. I'm going to make a little table of y equals 2x. I need at least 2 points. I like to make 3 points though, okay? So here's y equals 2x. You don't have to find the y-intercept if you don't want. It's kind of almost easier to just put in -1, 0, and 1. Those are 3 points that you can use just because those numbers are pretty small, okay? So when x is -1, what happens to y? Y equals 2 times -1, y equals -2. So when x is -1, y is -2. Then we're going to do y equals 2x when x is 0. Y equals 2 times 0. So y equals 0. And then our third one will be replacing x with +1. Y equals 2 times +1. So y equals 2. Okay, so when I graph that, I'm going to graph the points. So that's the graph y equals 2x, and it includes the points -1, -2, 0, 0, and 1, 2. Good? All right. Y equals 2x uses the points -1, -2, 0, 0, and 1, 2. -1, -2, 0, 0, 1, 2. That's y equals 2x. Good. All right, let's do the next one. Y equals 2x plus 4. So I'm going to do -1, 0, and 1 again. Y equals 2x plus 4. If it's equal to -1, y equals 2 times -1 plus 4. Y equals -2 plus 4. Y is 2. Now I'm going to do 0. Y equals 2x plus 4 when x is 0. Y equals 0 plus 4. Y equals 4 when x is 0. Then our last one, y equals 2x plus 4 when x equals 1. So y equals 2 times 1 plus 4. Y equals 6. So this is going to be the points -1, 2, 0, 4, and 1, 6. For y equals 2x plus 4, we have the points -1, 2, 0, 4, and 1, 6. So those were the points -1, sorry, -1 on the x, 2 on the y, 0 on x, 4 on y, and 1 on x, 6 on y. Oh, darn it, those look the same. Sorry, red and orange look the same on my computer screen. Still time to change. So that's going to be the graph of y equals 2x plus 4. Good. All right, and the next one is y equals 2x minus 3. So first we're going to just do x is -1, x is 0, and x is 1. Again, you do not have to use -1, 0, and 1. You can use any number you want, all right? So for -1, y equals 2 times -1 minus 3. Y equals -2 minus 3. Y equals -5. Next one, y equals 2x minus 3 when x is 0. Y equals 0 minus 3. Y equals -3. And the last one, y equals 2x minus 3. When x is 1, y equals 2 times 1 minus 3. Y equals 2 minus 3, so y equals -1. Good. So now our points for y equals 2x minus 3 are, oh, sorry, I forgot to write them over here. -1, -5, 0, -3, and 1, -1. Let's see what those look like when we graph it. -1, -5, 0, -3, 1, -1. And I did not need to use the points -1, 0, and 1. If I had used 5, I would have got the answer. Well, let's see. Where does this line up correctly? If I had used the number 3 for x, I would have got 3 for y. Okay. But that's the equation y equals 2x minus 3. And what you're meant to see here is that here is y equals 2x. When we add 4, each point, each x value, the y increases by 4. So instead of 0, it's now at 4. Instead of 2, it's now at 6. Instead of -2, it's now at 2. And then for 2x minus 3, it just goes down 3. So here for +4, it went up 4. For -3, it went down 3. +4, it went up 4. -3, it went down 3. Okay? All right, what if we just have the equation x equals 8? Create a table of at least 3 ordered pairs. And remember what I like to do? I like to go x is -1, x is 0, and x is 1. Yeah? If x is -1, x is 0, and x is 1. X equals 8 is our entire equation. So I've put in x equals -1, -1 equals 8. That's not possible. 0 equals 8, not possible. 1 equals 8, not possible, right? So I did not make a good table. What is 8? What would x be equal to that would make it true? 8, right? If x is equal to 8, that makes it true. What is our y when x is equal to 8? Our y is every single number. So when x is equal to 8, all it says is x is equal to 8. Eight is equal to 8 is always true. It doesn't matter if y is 1, if y is 2, or if y is -10. X will always be 8 and it will always be true. Let's graph this to show you what we're talking about. Good? So we're just talking about the equation x equals 8. See the line? Come back. That's the 0.80. That's the 0.81, also on the line. 8 zeros on the line. 8, sorry. 8, -1, also on the line. So every place that this line crosses y, it's just going to be x equals 8. So it can go on forever. It could be 8 -30 down here. It could be 820 up here. It could be anything, okay? Y must be 8, or sorry, x must be 8. Y can be anything for this one, okay? The next one they're going to ask us about is y equals 2. What do we see for y equals 2? It's always horizontal. It crosses at 0, 2, but it's also true for -1, 2. It's also true for 1, 2. It's true for any point where x is equal to, or where y is equal to 2. Okay? So those are just ones that you need to remember. If it says y equals 2, that's just going to be a horizontal line through y equals 2, through the 2. If it says x equals 8, that's going to be a vertical line through 8. Let me zoom out. So that's x equals 8, that's y equals 2. So for this one, y equals 2. If I say x is -1, 0, 1. If x is -1, y equals 2, y is still 2. If x is 0, y equals 2, y is still 2. If x is 1, y is still 2, right? So that's another way to think about this too. Here, x is equal to 8. If y is 1, x is still 8. If y is 2, x is still 8. If y is -10, x is still 8, okay? That means that all vertical lines, vertical means up and down, vertical lines have the general form of x equals and no y value. There's no y in the equation. All horizontal lines, that means they're going the long way, have the form of y equals and then the number. And then there's no x value in that equation. Okay? And that is all we're going to cover for linear equations today. Thank you guys so much. And please feel free to send me an email if you have any questions.